So a warm welcome to this code walkthrough talk. This is about the newly introduced feature in Pacific, which is CephFS mirroring, or rather CephFS snapshot mirroring. So the idea is to enable the cluster admin or the operator to, selectively add directories for snapshot synchronization to a remote Ceph file system. So the idea is to have to do it asynchronously, which means we have a bunch of daemons involved that do the job of copying data from one cluster to another. You can also kind of synchronize data from one file system to another file system in the same cluster. That's pretty much transparent. So the idea remains the same. Okay, so I plan to split up this talk into kind of 4 sections. The code walkthrough at least, starting with the structures involved. We have different things we need to persist in the cluster in Radas object. So where are what is stored where. So essentially what structures are involved and what gets persisted and where. That is the first part. The other part is the interface. So you see from the operators or the cluster admin's point of view, how to actually enable a directory in a Ceph file system for mirroring. Then we go into details of how it's handled. Like, there are a couple of things. So we have the manager module that provides the interface and the actual daemon that does the copying of data and snapshotting. Right. So let's start with the first section, which is the structure. Okay. So before moving on, there's the main concept in one of the concepts in mirroring, in CephFS mirroring, is a peer, or rather an entity, which is called a peer. So a peer is actually a remote endpoint that is attached to a file system. You can think of this as attaching a remote file system, which can be in a separate cluster over a WAN, to a file system in another cluster, which is like establishing a relationship between a primary file system in the primary cluster to file system in the secondary or the remote cluster. So that we have a concept called as peer. So what we would need to do is, obviously, when the operator or the cluster admin try to add a peer, all this data needs to be saved somewhere. The peer information, what we call, needs to be persisted somewhere. So that is persisted in FS map. So you can see we have a class file system here. CephFS map is just a file system map that's used by CephFS. You can subscribe to an FS map. It's just like you can subscribe to an OSD map, an MGR map, and things like that. So any updates to the FS map done by anyone in the cluster you get notified for with that particular changes. So what we do is to track the peers for a particular file system. We show the peer info in FS map, or rather in FS map contains a file system instance. So for that particular file system, we have mirror info. Mirror info is nothing but some basic information like is mirroring enabled or not, and a bunch of peers, which comes here. So peers is nothing but a set of peer, which is an endpoint. So a file system can have multiple peers, which means you can attach more than one peer to a file system, and the mirror daemon kinds of takes care of replicating the snapshots to each of the peers. So peer is identified by a UUID, which is like a unique identifier for that particular peer, and a cluster info. Cluster info contains just the right amount of information to actually reach out to the peer, to actually start talking to the peer, which is nothing but a cluster name, a file system name, and the client name. So by looking at this, you might think that the cluster name is a remote file system, a remote cluster name, and which is true because with this interface right now, what we require is that the remote cluster Ceph configuration file should be present in the source clusters or the primary clusters host. So that would involve the manager module, the host running the manager module, and the host running the mirror daemons. That is one part. But we can avoid this by something called as bootstrapping up here. We come to that later. But even to bootstrap a peer, we still need some information regarding that peer, just basically the UUID. So we'll come to that later regarding bootstrap. But for now, we can think that the remote cluster's configuration file is present in the primary cluster. So this is, and we have the usual encode decode routines in the source file. You have the cluster info, the peer, and the mirror info. And once you dump the file system, you get the peers if mirroring is enabled and you have peers. So the reason for storing this in FS map is the mirror daemons, to start replicating the dietary snapshots to the peers. They need to know about what peers have been added or removed, or the peer updates. So the mirror daemon kind of subscribes to the FS map, and once it gets an FS map, it goes through the peer list, and on peer update, it's just the diffs it needs to know. So if a mirroring was enabled and disabled, now it goes and detaches a peer and things like that. So that's for the peer, and some of the other data structures, and we'll cover this while going through the PyBind mirroring code, which is the manager module, because we store a bunch of things in Rados directly in some certain objects, so that will be covered later. But this is the essence of it. So this is the main thing where we store the peer information in FS map, so that anyone who's subscribed to the FS map can get a list of peers. Okay, so, and now I'll come to interface. So for interface, the best way, I guess, is to just open the docs and just explain the interface and the code. Okay. So the interface is provided by the manager module, which is called the mirroring module. So the mirroring module is disabled by default, and you need to enable it by running Ceph manager module enable mirroring. We'll go into detail for the manager module later. Okay, once that is done, you can enable mirroring on a file system. So where that is done is, so the interfaces are hooked up in the monitors. So we have certain FS. So the mirroring related commands are kind of suffixed with FS mirror. This is the internal interface that is used. But if you go to the manager interface, the manager interface is actually CephFS snapshot mirror enable. This calls into the monitor interface. So always make sure when you're using mirroring module, use the CephFS snapshot mirror prefix rather than CephFS mirror. It can be a bit confusing, but yeah. So here we define, we have, you can map this to, the actual interfaces, which is like enabling a particular file system for mirroring, disable it, add a peer, and remove a peer. Because all you need to do is put it on the FS map. So let's do that. So this is the handler for when you're adding a peer. You extract whatever is needed, such as the UUID, the remote cluster spec. So the spec is nothing but a tuple of the client name, which is used to access the remote file system, and the cluster name. So that's called the spec. You extract the spec, and then you operate on the FS map by the modify FS map call. and you just add a peer to it. So once that is done, the peer information gets recorded in FSMap, and anybody who has subscribed to the FSMap gets notified that there is an FSMap update, which in this case is a mirror daemon. We'll come to how it does that. But yeah, once it gets an update, it can figure out what peer updates has happened and such. Likewise, you can disable mirroring on a file system. It's pretty simplistic. Do the same thing again, remove peer, you go and operate on the FSMap, and you call peer remove. Peer add and peer remove interfaces in the FSMap is pretty simple. It just maintains a list of peers, so you just add or delete from it. Then yeah, I'll come to Bootstrap later. That's for the peer interface. So this is the main thing we have right now. So yeah, make sure to use the FS snapshot mirror interface rather than the CephFS mirror interface. Okay. And yeah, so the actual implementation of the FS snapshot mirror thing we'll explain in detail when we are doing the mirroring module code walkthrough. So the mirroring module also provides interfaces to add and remove directories, which are for mirroring. So you can add, using the FS snapshot mirror add, you can add a directory for mirroring and remove it likewise. One thing to note is only absolute directory paths are allowed. So if you the paths are normalized internally in the manager module. If you do something like A, B, go a directory up and B again, that's equivalent to A, B. So both are equivalent. Yeah, the important thing is once a directory is added for mirroring, any of its subdirectories or ancestors up till root are disallowed to be added for mirroring. That's because the way we synchronize snapshots, so the mirror daemon actually does a bulk copy of data, of the snapshot data from the primary to the remote file system, and then takes a snapshot with the same name as the snapshot being transferred in the remote file system. Due to that, it's a bit tricky to allow subdirectory and ancestors for mirroring, once we have configured a directory. So that is disallowed. So if you have added, say, in this case, D0, D1, D2, so the mirroring module doesn't allow you to add D1 and anything, below D2, which is like D3 and anything below that. Yeah, which means if you schedule the root of a file system for mirroring, you essentially cannot add any other directories in the file system for mirroring, because everything will be below root. All right, so yeah, that is the interface part. Let's do the actual fun part, which is the manager module. So yeah, manager module is in by bind mgr mirroring module. So yeah, so this is pretty much not interesting, this source, because all it does is sets up the commands. So you can see we have something called as enable mirror, disable peer add. These just dispatch to the actual machinery which is present in this source. By bind gr mirroring fs snapshot mirror.py. Right. So the module source just hands over, just dispatches the command to the actual implementation in the snapshot mirror source. So you can see you have enable, disable, peer add, peer remove, peer list. You can list a bunch of peers for a file system. We'll come to Bootstrap interface. You have this add directory, remove directory, the ones we just saw. The dir map and the mirror distribution are really not intuitive right now, and they are not really function for use, because we only support, or at least in Pacific right now, we support running just a single mirror daemon. But the machinery is already there to support running multiple mirror daemons in active mode, which means the directory load is spread across a bunch of mirror daemons for congruent synchronization. But for Pacific right now, we only support running a single mirror daemon. We plan to enable HA active pretty soon. So yeah, let's see. Okay, before we go into these each of these interfaces, let's see how the flow is done in the actual snapshot mirror part. Okay, so what happens is so if you see the snapshot mirror source, there are a couple of interesting things here. One is the manager module needs to know about which mirror daemons are running, or how many mirror daemons are running, or how to actually talk to a particular mirror daemon. The reason for that is the interface for adding and deleting and removing directories from mirroring is through the manager module, and the manager module needs to hand over these directories to the mirror daemons so that the mirror daemons can start synchronizing snapshots. So the manager module needs to know which mirror daemons are running and how to talk to them. Okay, so there are a couple of things here. There are a couple of structures involved here. So the manager module and the mirror daemons kind of cooperatively talk to each other using Rados objects via watch notify. So what happens is you have this special index object which lives in the metadata pool of the file system. And the file system, this is all in the primary file system, in the source file system. We have this CephFS underscore mirror object that is created when you enable mirroring for a file system. And it serves two purposes. One purpose is the OMAP key values in this particular object records which directories are added for mirroring. And the other purpose for this index object is to talk to the mirror daemons. It's kind of a keep alive handshake between the manager module and the mirror daemons. So if you're aware of Rados watch notify, what can be done, which with watch notify in Ceph, a client can establish a watch on a particular Rados object, and you can have multiple clients establishing watch on that particular on an object, and some other entity, some other client can send a notify on that particular object. So all the watchers who are watching that object get notified. They get pinged that you have someone. So there is a message that can be handled. So it's kind of a broadcast. So in this case, you have this index object which is CephFS underscore mirror. And the mirror daemons, when they spawn, they establish a watch on this particular index object. And the manager module periodically sends a notify on that particular object, which means all the mirror daemons get this particular message and they reply back and they act back that message. And in the payload of the ACK, it has certain information about the payload has some information about the mirror daemon, such as its address and things like that, and the instance ID, which is internally used to kind of as an ID for a mirror daemon, and we'll see how that's used internally. But the essence is, using this watch notify broadcast, the manager module knows about how many mirror daemon instances are running. So that's done in the instance. So we have this instance watcher thing, which is nothing but, if you see bootstraps by doing a notify, so it's just an loop does it do is, so we try to do everything asynchronously, if possible. If not, we kind of spawn up threads to do that. But in this case, we added the AIO notify call to Rados on the Python binding. So once you do this, AI notify on mirror object prefix. Mirror object prefix is nothing but CephFS underscore mirror. So we have this well-named, object that the mirror daemons know and the manager modules know. So mirror daemons will establish a watch on it, and we kind of do a notify. Once that's done, if we have 5 mirror daemons running, all 5 of them kind of reply back, and this AI notify, the last parameter is the handle notify, which is the callback, which gets called when you get when we get acts back from the watcher. Once that's done, what we get is a list, which is a list of acknowledgements and a list of timeouts. So it's possible that some of the mirror daemons, for some reason, there was a network hiccup, or the mirror daemons didn't reply or whatever. So the mirror daemons that replied, those information, which is like the daemon ID, is the instance ID, and the payload ends up in ACK, which is a list. So you can have obviously more than that. And timeouts. Timeouts is which of the instances have timeout. Yeah. So what we do is we just go through it, figure out. So we have a notion of instance timeout. So if we keep on doing this AI notify broadcast, but if for some reason we have seen a mirror daemon earlier, but that has not responded for instance timeout seconds, which is like 30 seconds, we consider to be dead. So we consider that mirror daemon to be dead. So we go and blacklist it, it's possible that some of the directories would have been assigned to that mirror daemon. So we go and shuffle those directories across other daemons. So we'll come to that, the HA part. But this is the way we actually, discover how many the running daemons. So where all this gets tied up is in the main snapshot mirror source, where we have this instance watcher. So we set up instance watcher, and once you set up a create an object, it starts in the background. So it continuously does a IO notify every second, and then we provided a listener, so it gives back saying that these are the instances that have been added, and these are the instances that have been removed. And we go and once we get the added and the removed instances, we can then construct a map of how many mirror daemons are running, and what directory should be assigned to what mirror daemon. Okay, so yeah, we'll see how this ties in into the internal machinery. But before doing that, I'll also talk about how directories are mapped to mirror daemons, and the way in which that's done using a state machine. So we have this. So if you see this module, we have this add dir, which calls into the add dir here. Okay, so once we want to add a directory for mirroring, we do some basic checks, like what is the file system mirrored and things like that. And once we have done those basic checks, we end up here. Okay, so this purging thing is something internal when you're removing directories. But the main thing to see is we have something called as a policy. So the policy defines how directories get mapped to mirrored instances or mirror daemons. So right now we support a simple M by N policy. It's like if you have M directories and N mirror daemons, so you kind of do a simple M by N and just assign, if you have say 100 directories and 5 mirror daemons, so each of them get 20 directories to handle. But to figure out, to actually map a particular directory to a particular mirror daemon, so the whole flow is kind of tied into a state machine. So we'll see that. But before that, let's go into a policy. So we have this in dir map, which kind of tells you that we are mapping directories and we have a policy in there. So add directory. So how all this ties up is, as I said, it's a state machine. So we have a state transition here. Not sure if this is visible. Is this readable or how is it? Can you make sense of it? Because it's kind of wrapped. Anyone?
Yeah, it's okay for me.
Okay, fine. Yeah. Well, you can open the source and see it yourself. Yeah, I'll just go through it. Okay, so we have this state machine that kind of governs how a particular action should be taken on a directory. So let's do this. Let's see a simplistic case of adding a directory. Once you're adding a directory for it's a fresh directory, so it's kind of the mirror daemon has, so the manager module has not seen it earlier, which means it has not mapped it earlier. So it's kind of fresh. So once you add a directory, you follow. So from line this, so where you see state associating up till this. So this is the state machine that handles state machine part that handles that governs how a directory is assigned to a particular mirror daemon. So if you see this state machine, state transition table, it's nothing but a map between something called as a transition key and the actual transition that needs to be done. So a transition key is nothing but the action, which is like what we need to do. Action type, which is like do we need to update the map? Do we need to remove it from the map? And acquire release. I'll come to acquire release later. That's kind of tied in with the AI notify thing. But yeah, so we have states and we have actions and policy action. So before going to state machine details, let me quickly go through this. So we have policy action, which is like you can either map, unmap, or remove a directory, which is like, so mapping action, policy action type map is like assign a particular directory to a particular mirror daemon instance. Unmap is the reverse, which is like you need to kind of disassociate, so remove it from the map. And remove is kind of, you need to actually go and remove it, which means so we maintain it on disk. As I said, the CephFS mirror object has OMAP key values, which contains the list of directories. And the key is the directory name prefixed by an identifier, and the value is the actual contains a blob of which daemon instance is this particular directory assigned to. So I'll come to that. So this is policy. Then we have action type. So once we go into the state machine, you'll see, once you have mapped a particular directory to a mirror instance, you need to kind of save that particular map on disk. So that's kind of, the map update part. The map remove is the reverse. It's like when you're disassociating a particular directory from a mirror instance, you need to remove that particular map from the OMAP key values. So that's map remove. Acquire release. So these acquire release are messages that are sent to the mirror daemon, and this uses AI notify again. And that's so the acquire release messages do not go through the CephFS mirror object, because as I said, so the mirror daemons are listening, are kind of watching that particular object. So if you want to talk to a particular mirror daemon, going through CephFS mirror object or notifying through CephFS mirror object doesn't work because that kind of broadcasts it to all the daemons. So we have per daemon index object. So that is like, um, so that object is CephFS underscore mirror dot an instance ID. Okay, so the only daemon, so only one daemon is listening on that particular object because it's private to that object. So the instance ID is the Rados ID that's used by the mirror daemon. And how does the manager module know about the instance ID? Well, if you see the instance watcher class, which I just went to here, the payload that is sent by the mirror daemons in response to the air notify contains the ID it's using. So it's the same ID that's used as the suffix in the CephFS mirror dot private index object for that particular mirror daemon. So acquire release is not broadcast. It's only for a particular mirror daemon. So the idea is to acquire is like assigning a message that says and that is sent by the manager module to the mirror daemon. That says this particular directory is assigned to you, or which means essentially means that that particular mirror daemon needs to is now responsible for synchronizing snapshot for that particular directory. Release is the other way around, so it's already assigned to a particular mirror daemon, and now you want to say that you're no longer responsible for synchronizing this particular directory snapshots, so go ahead and release it. So yeah. Okay, so that's the action type. Then we have state. So when you're adding or removing a directory, it goes through a bunch of states. It starts with like associating state, which is like when you freshly add a directory. So the daemon is kind of so the manager module is kind of figuring out that now this is a fresh directory and needs to be associated to a particular mirror instance. Once it's kind of, so that state is associating, and once you have sent and acquire, once you have done a update map, because you will see the state machine. When you're adding a directory, you need to first figure out where the directory is assigned, where should the directory be assigned, which mirror daemon should the directory be assigned to based on the m by n policy. Once that's done, you do a map update, which is like storing the key value pair on disk, which says now this particular directory is assigned to this particular mirror daemon. Then you go and send an acquire message to that particular daemon, and once that's done, you move the state to associated. So we'll see that here. But yeah, so we have this initializing state. The only difference between initializing and associating is so it's possible that once a directory is assigned to a particular mirror daemon, we don't store the states on disk. Okay, so once the state moves to associated, if the manager module if there's a manager restart, right? So what happens is during startup, the mirroring module reads the OMAP key value pairs, and for each of those directories in that list, they start with initializing state. Initializing is kind of like it has seen the particular directory earlier. It has in its record. It just needs to verify with the mirror daemon that is it still valid, or it's the same acquire message that goes to that particular to the mirror daemon. But it's kind of it's if you see the state machine, it's kind of short circuit. It doesn't go through all the states. It's like initializing, and once we get an ACK back from the mirror daemon, we just move it to associated. So we'll see that associating as shuffling. Yeah, so shuffling is the interesting part, which we right now we don't support it because we only support running a single mirror daemon. But the idea is once you have mirror daemons coming and going, spawning and getting restarted, we have this state shuffling which says that we are this shuffling state in the state machine is kind of like telling a mirror daemon to release a directory and then sending an acquire message to another mirror daemon to acquire that directory. So we'll come to that. So let's go to the state machine. So let's start with the simplistic case of associating. So once we are associating a particular directory, so the actual policy code here, takes the state machine and drives the state machine from one state to another for an event. Okay, so we start with a state which is like associating, and the current action type is like none. So this is just the start. So what we do is we do a map update. Coming to policy, if you see, there are a bunch of helper routines here that drive the state machine. So once you know that so it's like you call the state machine call that says hey, this is the current state and this is the action type. What do I know? What is the next transition do I perform? And that is all tied up in here. So the essence is if you are actually mapping, so this is because we are adding a directory. So you need to map it to a particular instance. So we do this map call, which is the m by n policy that I was talking about. So which means so dead instances, we'll come to that later, but for the simplistic case, we iterate to the map. So we maintain a map like instance to dir map, which is like the instance ID and the directories that is assigned to it. The instance ID is the CephFS mirror Radar's instance ID. We iterate that, and once we find out which one has the low candidate based on the m by n policy, we kind of get that, and we assign. So we create a state which says this a dis state. This state has just enough information to kind of the instance ID is mapped to. That's a kind of a back pointer. The state stalled, it's an internal state when no mirror daemons are available, so there's nothing to map to. So we say that this directory is stalled. And the actual transition. So the map thing here, the map function returns, or rather says, maps a particular directory to an instance. And once that's done, once that's done, so the call here is done by the all the state machine is, so the logic is in the policy source. The state machine is driven in the snapshot mirror source. It's an asynchronous state machine. So it's like so you have so the state machine being asynchronous means so it's timer based. So it tries to see if there's any work to be done each second. So the way it works is you have this self.dir paths, which has a list of directories for which some action should be taken depending on the current state. So the other parts of the code, if you see add directory, it just does minimal and appends that particular and adds the directory to the self.dir paths. And this asynchronous timer-based state machine, every second, it iterates through what's in dir paths and kind of for that particular directory sees the calls into policy. So the policy is like knows what state it is in and what action needs to be taken, and once it knows what action to be taken, it tells the caller that this is the action that is the next action to be taken. So we saw that in the state transition part, we have map update, map remove, acquire release. So for a particular directory, if it's being added, if it's a fresh add, first time add, so it does a map update. So map update is like it saves that particular directory key value OMAP in the CephFS mirror OMAP thing. I'll go through that in a minute. But the idea is, so there can be some directories that needs map updates, some directories that need map removal. For some directories, you need to send acquire, and for the others, release. So for updates, for map updates and map removals, we call this update mapping. That is an asynchronous call, or rather, it's kind of, you know, it's kind of uses the async API, Rados API, to update and remove the OMAP values from that particular object. And once that's done, is calls this callback. We'll see what happens there. But for other directories which need acquire and release, so we know which instance ID, CephFS mirror instance ID needs to be send the acquire and release messages, because the policy already maintains that this directory is assigned to this particular mirror instance. So we just look it up, which ends up in lookup info, and using that instance ID, we can send the acquire and release message here. So how that's done is, if you recall, so there's this private index object, which is like suffixed by the instance ID. So once you say, this is, notify this particular directory, with this message. So this message is nothing but, it can be of acquire type or release type. The mode actually tells whether this directory needs to be added in the queue by the mirror daemon, or if it's already there, just don't back off and not bother about it, because maybe this is getting reassigned to some other mirror daemon. So we have this acquire and release messages sent to a particular mirror daemon instance, and that's done here. If you see, you extract the instance ID, and you create this object name instance object, which is nothing but the mirror object prefix, which is CephFS underscore mirror, suffix by the instance ID. So message that is sent to this particular object using the AIO notify is sent to only one particular mirror daemon instance, and that acts back, and once that acts back, you have this PRAC, so all this drives the state machine again. So once you send an acquire message to a particular mirror daemon, it acts back saying that it has seen that message, and it's now responsible for that particular directory. We now need to move states. So if you see, what happened is, when you added a directory, depending on the state transition here, we first did a map update, which is like mapping. First you map it in memory, saying that this directory is assigned to this particular instance ID, daemon instance ID. So the first step is do map update, which means record it on disk, which happens here, update mapping. So we'll go to that, but you can think of this as just doing a Rados call that sets the key value pairs. Once that is done, the state machine now needs to be transitioned to the next state. For that, what happens is you have this callback. So since this is an asynchronous call, once you have done all these updates and removals, this callback gets invoked, continue action. So it has a bunch of updates and removals. So what we do is iterate through a list of updates, and collect what directories were scheduled for updates, and again what directories were scheduled for removals, and then do a schedule action. Schedule action is pretty simple. All it does is just add these directories to self.dir paths, which, if you recall, the asynchronous state machine driver actually iterates these dir paths and tries the state machine via the policy. So once you are done updating the map on disk, these directories get added back again in the list so that the state machine can be moved forward. So now the state is map update, and it's still associating. So the next state is acquire. So you see how it's going, right? You first store the instance map on disk, and then here, if you see, it's acquire. So now the state machine here will send an acquire message to that particular mirror daemon. And once it, yeah, okay. So let's talk about what happens here, right? So once you notify, you call this notifier with saying that, this dir path, send this message to that particular instance, CephFS mirror instance, you call handle PRAC. Yeah, so this gets called when we actually receive an ACK from the CephFS mirror daemons. We say, we again, drive that to the state machine continue action, which again, does the same thing, goes into updates, so the updates here is just that particular directory path that was that we recently sent an acquire message to a particular mirror daemon. Again, that gets added to the list of dir paths, and that's driven again. So process updates, yeah. Okay, so once that acquire message has been sent and you get an ACK back, basically your state machine is kind of done, right? You were in associating, you got an acquire message, and you transition to final state associated, which means now this particular directory has been associated to that particular mirror instance. Not only that, it's associated in the sense the mirror daemon knows about it and is handling it, and the manager module knows about it by way of the on-disk OMAP key value pair. So the key is the directory path with a prefix, and the value is a blob. As I said, it contains the instance ID, which for which this directory has mapped to the CephFS mirror instance ID. So you can see here, what happens if the manager restarts. So this whole directory set is loaded again by reading the OMAP in this particular object, and then now we started with initializing state, which is, as I said, it doesn't go through the whole update map thing. It just says, initializing. It just sends a acquire message, and then once it gets an ACK for the acquire message, again moves it to associated state. So that's the state machine driver here. You can follow the other paths such as disassociating. It's just the reverse. We can quickly go through it. You want to disassociate a directory from a mirror instance. The first thing you have to do is tell the mirror daemon to back off replicating that particular, synchronizing that particular directory snapshot. So we send a release message. And then we do an unmap. So we have this start policy action, end policy action, internally we do all these jugglery around. But once it gets a release ACK, it does an unmap. Unmap is like, it just removes it, disassociates the directory from the instance in the internal memory map it's using. Once that is done, you just do a remove. So map remove, again, as I said, it removes the on-disk OMAP key value for that particular directory. And once that's done, you're done, right? You are kind of unassociated. Now move this to unassociated state, which is like, now no one knows about this directory. We have removed it from a map. CephFS mirror daemon has kind of, backed off synchronizing those snapshots. So shuffling, yeah. So shuffling, you can see, what it is. It's pretty simple. So we need to kind of tell a mirror daemon to stop replicating snapshots for that directory, which is like sending a release message, then kind of mapping it to another instance and sending an acquire message. But before that, you do a release. So the essence is you do a release, then do a map update, and then acquire. So you can see here, right? We started with doing a release, unmap it, so you remove it from memory, but you don't do a map remove here as we did it in the disassociating state. After unmapping it from memory, we do a map. It's like it finds a new instance, mirror daemon instance to map to. Once that's done, do a map update. So earlier it was like map to 1 through 3, 4. Now it's like 5, 6, 7. So we store that we update the on-disk map. Once that's done, we send an acquire to the new instance ID that this has been mapped to. And once that's done, we move it to associated state. So that's the essence of it. There's some minor details like, once a directory is added, in add there, we could actually just go ahead and schedule that particular directory for state machine updates by updating the list of directories, self.dir state, whatever, what it was called, self.dir paths. But, it could be that, you just added, it's still sitting in memory, but the manager module goes down. But we have back to the operator that saying that, we are now handling this directory. But if the manager restarts in between, you're kind of now the directories are known. Nobody knows about it. So what we do is once you add a directory, we store just the minimal information on disk, so that if manager restarts, we can pick up the directory again and start the state transitions. So for that, we to create this blob. This is the actual blob that gets stored in the OMAP value. It has a version unused now because we don't. It's just the first version. There's no. If we add fields to it, we bump up the version and then handle accordingly. We store an empty instance ID because we have not yet mapped it. And last shuffle. This last shuffle is basically would be used when we do HA. So you don't want to kind of move directories around frequently once you see a new mirror daemon, or one of the if like mirror daemons keep joining again and again, in the sense you see, so you have start with 2 mirror daemons, then 3, 4 in rapid intervals. You don't want to kind of move these directories around so soon, because you'll just be wasting time in moving these directories rather than actually synchronizing snapshots. So we use this last shuffle time. So when we shuffle a directory, or when you assign a particular directory to an instance, we record the time when it was added, and then we don't, even if it's even if based on the M by N policy or any other policy, you can spread the load across. We won't do it because it was just shuffled. So it's just a minor detail. This is unused right now because we don't do HA. But yeah, once we start doing that, the policy needs to take care of all these additional variables to decide when to move a directory. So yeah, once that's done, we update the mapping, and once we have it on disk, which means even if we restart, we know about that particular directory path. We can can react back saying that this is now scheduled. But yeah, everything is like asynchronous. So let's see. We were going to see how does update mapping work. I can quickly do that. Yeah. So update mapping takes, this is the class that gets called update mapping. Yep. I think, let's see. Dot update mapping. Okay, yeah. So yeah, since it's asynchronous, we kind of record what is we assign a request ID for that particular async call. Yeah, we call this update dir map request, which is here, takes a update map, which is like contains the key value pairs, and removals, which is just the key. And how we do it is we don't load the OSD with thousands of ops. We kind of slice them. So we have this. We do it in slices. So if you have like thousands of ops to be updated, or rather thousands of updates to be applied for that particular object, the OMAP key values, you kind of do it every two. You kind of send 256 ops at a time to the OSD. Yeah, this is I kind of learned it when I was doing RBD stuff. So if you just send like thousands and thousands of ops to OSD, you get the slow ops thing and all kinds of warnings. So we kind of do. So the recommended way was to do this in slices. We do the same. if you see, it's kind of a mini state machine again. So you slice it, right? So you gather updates and gather deletes. Again, it uses the AIO API, Rados API to do OMAP updates. And once that's done, this call is done. You call handle update. Handle update again calls into send update again, which is like process the next 256 updates. If nothing is there, you just, you're done. You call finish. Finish is like, it calls the onFinish callback. OnFinish callback is nothing but the async callback here we provide. So the idea is to kind of, once that is done, once you do a bunch of OMAP updates, you call into the state machine again, which kind of, which means that, once you do an out this update, gather the list of directories, and then put it in the their path list again, so that the state machine can process it again. Okay, yeah, so that's how it's done. Yeah, okay, then we are coming back to how instances are handled, right? So we had this instance watcher that notifies us of new instances and instances which might not exist. So that's again, once this thing figures out what are new instances and old instances, kinds of calls into a listener. So we have this instance listener that's provided. Sorry, instance listener. Yeah, so instance listener, it calls this handle instances from here, gets a list of instances that have been added and removed. So we call into update instances. Again, what we do is for instances that have been removed, we blocklist those instances. Says blocklist is nothing but doing a mon call, I guess. Yeah, we do this OSD blocklist top, and the adder. Blocklist the instances that have been removed, because it might be the case that there's a network hiccup and the mirror daemon is not necessarily down offline. So once we blocklist its address, the mirror daemon figures out that it has been blocklisted, and then it goes and backs up again. Yeah, for the instances that have been added, again we store them on. Sorry, where do we go? Update instances. Yep. For instances that have been added, we store the instance ID on disk. And again, once that's done, we send this update instance request. I think this is again in the update thing. Yeah, update instance request, same thing. It takes a bunch of instances that have been added and removed. And again, using that slicing for 256, does 256 updates at a time. And once that's done, acts back. So we call this handle update instances. Once that's done, handle update now. Will update instances. Again, we have these instances that have been added and removed. So what we do is we again do extract out what directories have been mapped to that particular instances. If it was removed, we need to kind of move all the directories that have been directory paths that have been assigned to that particular instance to other instances. This is not shuffling because the instance no longer exists, so we need to move everything to other instance. And for those that have been, once you have added a new instance, recorded it on disk, call this. You check the policy again and call this add instances. This is where shuffling happens actually. So once a new instance is seen, we figure out how many instances we have now, how many directories we have, and try to spread the load across. And we return a bunch of directories that need shuffle. So again, if you see, we have added those directories back to the list for which the asynchronous state machine needs to be done. And in this case, we'll say no. It's so we saw the action type as, remember this, we saw it was now the state as, so we set the state for those directories that need shuffling as shuffling, and the state machine driver again does the same thing. Follows this, release from the old instance ID, unmap it in memory, map again, find a new instance ID, do a map update on disk, and then send an acquire to the new instance, CephFS mirror instance. And that's how shuffling is done. Yep, I think that's pretty much it. Remove dir is, yeah, we again do the same, we kind of store on disk saying that we update the map saying that now it's purging, because we just can't schedule an action in memory and then forget about it, because if the manager module goes down, restarts, we won't know that this directory was removed. So we put this purging identifier saying that, it's in process of removal. So if the manager module restart, it sees this purging key, and then adjusts the state accordingly. So if it was like associating, initializing earlier, now it moves it to disassociating state. I think so that's done here. Yep. If you have purging, you just flip the state and allow the state machine to continue. So if it's, yeah. Again, so we here, we just record it on disk, and then once the update is done, we can act back to the operator, and the state machine can asynchronously continues. Yep. That's pretty much it, I guess. I think we're just about time too. So we didn't get time to do the actual mirror daemon stuff. So I guess that will be part 2. Yeah. All right. Thanks guys for attending. We'll probably do a part 2 pretty soon on this and cover the actual daemon code. Thanks guys.
Thank you, Venky.